Hello community! OpenAI has given us the new O3 model, and I know everybody is applying right now for early access for the safety testing of O3. But you know what is really fascinating? Where did O3 fail? Let's have a look at these examples. And they are here the official ARC-AGI task with the specific number, and I'll give you the reference in a minute. So here we have it. Here we have examples, an input and an output. Another input and an output example, and another input and an output example. And if my child would understand now the common pattern and would say, okay, if this is not a test input, what would be the test output? But O3 failed in this. Other ideas, let's explore this. Have a look at this. We have the same structure. So you see we have here our blue indicators here at the borders, and if you connect those two blue indicators, all the red boxes that are on these rays of blue, they also become blue. Now, we as humans, we see this, we understand this, but given that this is now the test input, and you see that test input increases the complexity also just a little bit with a second line, but this is where even O3 fails. And this is amazing because it does not just fail in the low compute mode, but it fails in the high compute mode. So at the end of this video, we will talk, is now O3 this AGI model? But let's look at another example, because this is now real simple. And this is an example where O3 fails. Look at this. The blue one, the red one, the green one, and the light blue one. And you see all those examples, and then you're given this, and there's an additional layer of complexity because suddenly we have now here the second object. But if we have made it to these examples and we understood, if suddenly we have here a second example and only one color-coded bar, we understand how to apply it now to a second. But if we have now the test task to apply to a third one, O3 fails. So much about the performance of O3, and this provides us an insight into the performance and the inner workings of O3. Now let's look at the performance data. And this is amazing. So on the x-axis we have the costs per single task, $100, $1,000, $2,000. And here you have here a particular performance score on a particular test dataset I'm going to show you in a minute. Just have a look at those two new indicators that we get for the performance data. Here we have on our ARC-AGI semi-private evaluation dataset, here we have the O3 in the low compute version, has a performance of 76%, and here we have a performance of 88% in the high compute version. Now, if we compare this now to the O1 model, that you might currently pay $200 per month, you see if we have the O1 low, the O1 medium, and the O1 high performance data, they go from 25% to maximum 32% performance in this particular semi-private evaluation dataset. So the jump from O1 at 30% to 76 or maybe even close to 90% is a significant performance jump. Let's have a closer look at this. If you want to know here about the particular evaluation dataset that O3 was evaluated against, here you have the technical report from December 9, 2024. And to make it easy for you, if you do not want to read the complete report, the semi-private ARC-AGI evaluation dataset has 100 specific tasks specifically designed to assess here the model's generalization capabilities on novel, unseen problems. It is withheld from the public because you don't want to have here a contamination here with your training dataset. And the other evaluation dataset and the semi-private evaluation dataset is here a very particular intermediary between the public available dataset and the real private dataset for calculating here the calculation. we have a beautiful post here from Francois, and he given us here this exactly evaluation data set because OpenAI asked him before O3 was published to evaluate here the performance of O3. And he tells us here, beautiful. So as I shown you here, 75% on the semi-private evaluation data set in a low compute mode, which cost about $20 per task. And we go up to 87.5, so this 88% in the high compute mode of O3, which would cost thousands of US dollars per task. So just some rumors on the internet I've seen just hours ago, there was the idea that we started here by OpenAI with a $20 per month. Then we have now for O1 the $200 per month. And the internet is currently agreeing that the next step will be a $2,000 per month. But this is absolutely not possible because think, even a single task would cost already thousands of US dollars per one task. So this price, even of $2,000 per month, is, I don't think, not a reliable idea. Now we have the data because this ARC price here is really transparent in the data. And if you go today, just updated 10 hours ago, to their GitHub repo, we have the data. We have the results by OpenAI O3. And those are also my source because I wanted to have reliable data from persons who really tested this and were asked by OpenAI to perform the tests on O3. So you go there and you get an understanding. And those data are the basis of my understanding I want to show you. Because I ask myself, how does O3 work? How is it possible to gain those performance jumps when everybody told us, hey, pre-training, no, there's no scaling anymore and whatever. So how is this result possible? And just to remind you, from 30% to close to 90%. But at extreme cost, at extreme energy. But let's understand it from a theoretical point of view. Now, again, if you go to ARC price or here to GitHub, you get the prompt examples and you get a beautiful blog post here by Francois. And if you are really interested in, read this technical report. Because there he gives us here the exact ideas and further details. So he says, at OpenAI Interaction, we tested here the two levels. Those are the two levels that you know on the semi-private evaluation dataset. We have here the 100 task. We have here the low and the high performance if you want. The score that we achieved, the 75 and the 87.5 that you already have seen. Now, they also have a variable sample size. The high efficiency go with a sample size of 6. The low efficiency go with a sample size of 1024. And you see, tokens 33 million, close to 6 billion tokens, unbelievable. And the cost per task, and they were only allowed, OpenAI asked them not to publish here the cost of task for the low version, but listen, if one cost per task is here $20 here for the low score, then for the high score version, since we do have AGI as humans, so we have here the 75 to 76%. This is at $20, okay? So if we have here now the $1,000 mark per task, the cost per task, and this is here, the end is at $2,000, we can estimate, let's say, $1,800 per single task for the high performance mode of O3. And remember, those are the cost, not the price OpenAI will ask you to pay. We continue with Francois, and he says, hey, we worked with OpenAI to test here O3 on this particular evaluation dataset. And he says, we believe it represents a significant real breakthrough in getting AI to adapt to novel tasks. And please note, I will continue now this video to focus on novel tasks. Not on tasks that are familiar, tasks that are in the training dataset, tasks that every AI system has seen already a million times. We will experience how good is it at unseen tasks. And Francois tells us, for now we can only speculate about the exact specifics of how O3 works, but he says the core mechanism, and he was testing this model here quite intensively, appears to be a natural language program search and execution within the token space. So this means at the test time, at inference time, O3 searches over the space of all possible chain of sorts, describing the steps required to solve the task in a fashion that is not too dissimilar to AlphaZero style Monte Carlo tree search. And he assumes that this search is presumably guided by some kind of an internal evaluator AI model. This is some absolute fascinating information he's providing us. So during inference time, we have now a complete new task. And you know, the technical terms are test time compute, or everything up to test time training, where we really do kind of a fine-tuning in the inference run. So I would say, hey, if you look at the time per task execution of O3, and you will see it has more than 13 minutes when you say, this is my prompt, go, then you have to wait 13 minutes for the result by OpenAI. It seems reasonable that there's quite a lot of going on. Eh? And if you pay close to $2,000 per single task, yes, I think this will be some extreme computing. But you know what this means? This means we have to do a pure inference computation on an otherwise perfectly pre-trained, perfectly fine-tuned, and perfectly preference-aligned large language model. And this made me thinking, so wait a second. We spent millions, not me, OpenAI, whatever company, millions of dollars to pre-train, to fine-tune, to align this large language model, and then even the vision language model. And now you tell me that the performance is not there, and now you tell me that I have to have a complete complex inference computation, maybe with a Monte Carlo tree search, in addition to this? And François goes on, and this is here a quotation mark, effectively O3 represents a form of deep learning guided program search. And the model, O3, does test time search over a space of programs, and in this case they are natural language programs, so the space of chain of sorts, or more complex tree of sorts, or forest of sorts, whatever will be the next step in the evolution of this, that describe the steps to solve the task at hand, guided, this search here, by a deep learning prior, and this is here the base language model. So this is now interesting, because suddenly we have the pre-training, the fine-tuning, and the DPO alignment, and then we have the real-world task by the user. And for the real-world task, this system with thousands of GPUs needs 13 minutes to come up with a correct answer. And what it does in those 13 minutes is not the interesting part. Yeah? Test time search over a space of programs. This is constituted here by a different set of chain of sorts, or even some more complex objects. And François tells us the reason why solving a single ARC-AGI task can end up taking tens of millions of tokens and cost thousands of US dollars is because this search process has to explore an enormous number of all possible paths through this huge program space that we learned during pre-training, supervised fine-tuning, and alignment, including all the backtracking that we know from the Monte Carlo tree search algorithms. And if you want to learn the next step, the forest of sort computation, if we are in test time compute, starting here from OpenAI 01 with their long chain of sorts reasoning structure, I show you here in this particular video all the technical details about the forest of sorts. Now he becomes clearer and clearer that yeah, it is not the perfect pre-training, not the perfect fine-tuning, not the perfect alignment. If you really want to have a high-performance system, we have to talk now about test time, training test time, calculation test time, adaptation. And I have to tell you, I thought this is impressive. But the very next moment I thought, wait a second. So for unseen tasks, and this is the only focus we have here with this particular evaluation data set in the version 1, by the way, all the trained knowledge of the pre-training, of the fine-tuning, and of the alignment, all this is gone because all of this is useless at inference time if we have a real-world prompt, useless to apply the current pattern of the solution from all of this pre-training and fine-tuning, because it will not find the solution. Is this what you're telling me? Because Francois tells us clearly, then we have to start a new process during this inference compute, this up to 13 minutes that he showed us, to search the mathematical space of all possible solution. And maybe this is the space where the functional generative is here, the chain of thoughts, or a forest of thought. So again, but now with the specific task by the user, we run now in the inference here this new process. And I think this is absolutely fascinating because it shows us that somehow OpenAI decided that the pre-training and fine-tuning and alignment is all beautiful and there are a lot of beautiful optimization methodologies. But if you want to make a jump, you have to look at the test time adaptation. And honestly, when I read this just hours ago, I thought this breaks my understanding of current AI optimization techniques. And I asked myself, does this mean, so all of this fine-tuning that we do, all of this DPO alignment, it only works for a similar task by the user? Only if the task by the user are similar, whatever similar means now, similar to the training data distribution that we have in the pre-training, in the supervised fine-tuning, and in the alignment phase, in the reinforcement learning phase? Because if a new task is now too different from anything seen and trained on, the AI fails. And I mean really fails, and I mean there has a real low performance indicator. And look just at the ARC test results of all the other models that don't have this test time compute. Because we have to start a complete new search process during test time, kind of an inference compute with a Monte Carlo tree search for the particular task is presented now in the real-world example by the user. So amazing for me to learn if the new unseen task is too different, is not similar enough to the training data distribution, this AI system will fail. So all of this talk about the AI will come up with some beautiful emergent intelligence, and the AI will understand the generalization patterns. I think with the performance of AO3, OpenAI showed us that this is not the case. If you disagree with me, hey, there are the comments for this video. Now, if you want to learn more about test time training and test time adaptation in detail, I have a technical videos in which I explain the inner workings, and here the test time optimized AI reasoning computational code structures as developed by MIT Massachusetts Institute of Technology. I show you here in this video where we scale the inference-based reasoning exactly on test time. Or if you want to go even further, deeper, more technical, I have here for the reasoning process here at the test time training adaptation process, some novel policy reward ideas with a Monte Carlo tree search in exactly this space. I produced these videos 2 weeks ago because I had a feeling that those new technologies will become important for us as an AI community. So coming back to O3 and Francois now, Francois tells us, regardless, the current performance represents here a remarkable achievement and a clear confirmation that this intuition-guided test time search over the program space is a powerful paradigm to build the AI system that can adapt to arbitrary tasks. And he tells us, the new ARC-AGI 2 benchmark to be published 2025 is already designed to further challenge O3, and it will highlight and focus on the limitation of O3 and will be the benchmark to beat. And this is the reason why I started this video and I showed you where O3 failed. Where is O3 not able to deduct the hidden pattern, where a chain of thought is not able, even from billions and maybe trillions of training tokens, to come up with a solution. Even if it has 10,000 GPUs and I don't know how many months of pre-training, it will fail to discover simple patterns. And yeah, now to all my YouTuber who love a good AGI story, I'm so sorry, but I have to tell you, and Francois agrees here, O3 is not AGI. And I know you will read in the news that it is, but if you understand it a little bit more from a technical point of view, if you look and read here the technical reports and the evaluation reports by ARC, you will see that it fails on simple tasks, as I've shown you, and it remains dependent on the human-created data for generating and evaluating our chain of thoughts. It fails here quite significant if the training data are not the highest possible quality. And this is, I would say, of course. And O3 lacks some autonomous grounding in reality and relies here only on the token space evaluation, which it is a limiting factor here, especially in the robustness in out-of-distribution task. So again, we are back to the old mantra. Your data, the quality of your data, are the most important factor for a good performant LLM. How many processes we build in the pre-training, in the fine-tuning, in the DPO alignment, in the reinforcement learning training methodologies, I think if we look at O3, we understand that all of those have come to kind of a saturation. But now the new frontier, the undiscovered performance that we are gonna achieve in the next year will maybe be with all of this test time compute, test time training, test time adaptation during the inference, where we will have to wait 13 minutes, 15 minutes, maybe if you really go to high performance, up to an hour for an answer. And the AI builds here a world of possible solutions and then spends extreme resources to going again with the real task by the user through all of this possible solution until it really comes up with the correct solution. I think this is amazing what will await us in the year 2025. So this is just 10 hours after OpenAI released O3. This is what I could find out. This is my current knowledge that I have 10 hours after it was published. And I hope I've given you some additional information, maybe some new ideas. And I would be interested in your ideas, in your, what you know, what you have read. So why not share your thoughts in the comment of this video? It would be great to see you in my next video.